All right, everybody. So my first attempt at this failed, but here goes try number two. I've got a paint can and a phone holder, selfie stick, and some duct tape. And this is the solution for today because the other video I was taking would not upload. So what I'm going to do here is go through a chi-square problem, make sure that you guys have something to work off of in case you're struggling with the process. The question I'm going to do is number 25 from the questions that you guys were working on last week, the genetics practice questions or practice problems. So let's get started and we'll walk through this problem. So first things first, this is a genetics problem too. And there's a student who has an experiment where they, in the first part here, explain that she did a purebred cross and figured out that this is a sex-linked trait based on the difference between male and female and how the trait was expressed. And now her next thing is she wants to figure out is this a recessive trait and dominant, or which versions are recessive and dominant. So in other words, the gene here is eye color, and she's looking to see you can have red or white eye color in fruit flies, and she wants to she thinks that white is recessive. So we can do a chi-square analysis to basically help us understand whether or not we want to support or refute the results that she comes up with. One little thing about this problem is it says 49 red-eyed females here. It's supposed to say males. And what they want us to do is calculate a chi-square value for the null that the white-eyed trait is sex-linked recessive. Give your answer to the nearest 10. All right, so let's work through that. So the first thing we have to do is figure out, okay, what are our observed and expected? We need those values to plug into the chi-square equation. So we already have observed. She already counted those from the 200 flies from the cross that she did. So we'll just kind of label these out. So our observed, she had 46 of the flies with red eyes that were female out of the 200. 52 were white eyes female. 53 were white eyes male, and 49 were red-eyed male. All right, so now we have to figure out, okay, well, what are the expected values? So the easiest way to do this in a genetic cross is to just do a Punnett square. That is the predicted value. So they tell you in the problem that she crosses two of the F1. So if you look back into the problem, the F1 females are, there's their two X chromosomes. They're all hybrid. So I'm going to use big R, assuming that that's the dominant red, and lowercase r for white eyes. And the males all had white eyes in this generation. So that's the male genotype. And I'm just being mindful, this is she figured out it was a sex-linked trait. So I put that Y there, and which can't carry the eye color allele. So now let's do a cross to get our values. So cross these up. So that's a red-eyed female, that's a white-eyed female, and this would be a red-eyed male, and this would be a white-eyed male. So it looks like our expected would be 25% chance of each, or a 1-to-1 to 1-to-1 ratio. So if we do that by 200, that's 50. So we'd expect basically an even split between all the traits. And if you look, kind of looks like she got that, but the chi-square is going to be used as a statistical means to basically say if there really is a difference between the observed and expected here, or if it just seems that way. Next step, we got to write out our equation. So to calculate chi-square, we need the sum of the observed minus the expected squared over the expected values. So we're going to add all those up, and that's going to provide us with a chi-square value that we can work with. If you'll probably eventually just have this equation down, but if you don't, and you're on the exam, they do put this in the formula card. So, all right, let's write down our equations. So I'm going to take from here. So chi-square equals, for the first one, 46 was our observed, 50 is always our expected, so that's easy. Squared over 50. And then I'm going to keep going because I got 1, 2, 3, 4 groups here. So there's how I'm going to calculate. And remember, I took these numbers from each of these groups. Now I'm just going to simplify here. And this would be my chi-square observed, by the way. So first equation gives me 0.32. I'm just going to the 10th like the problem asked me to. The next one for this one, and this one, the final one. And we just add all those up, and that'll give us 0.6, about somewhere in there. So that's my chi-square observed. Now I can't answer the question yet. I need to figure out the chi-square critical value, and that's where the degrees of freedom come in. So the degrees of freedom is the number of groups minus 1. So in this case, I have 1, 2, 3, 4 groups, so my degrees of freedom is 3. So now that I know that, I'm going to look over at this chart, and I've already circled it here, but I have to just go figure out my degrees of freedom. So I have 3, so I circled that, and then the probability, or what p-value I'm going to choose. In bio, we typically choose 0.05. I'm not going to explain the math behind it, but that's what you want to go for. And move over in the chart. So my chi-critical value is 7.82. This chart gives you the same thing, just a different way. There's the degrees of freedom. There's my p-value or probability, and then just go down. It's 7.81, a little different, but I don't know why, but that's okay. So chi-critical is 7.81, and now you really just need to look at these two numbers and figure out whether you're going to reject the null or fail to reject the null hypothesis. So it says here, give your answer to the nearest tenth. So we got that. We pretty much already answered the problem. If you want to go to the extra step of saying what we would do here, in this case we would fail to reject the null because our chi-observed value is actually lower than the chi-critical. So it doesn't kind of meet that threshold to say that we can refute the hypothesis. So in other words, the pattern that she's seeing here doesn't, or we're saying that there's not enough here to support that the white eye gene is recessive. So that's the value of this and what it's used for. And just kind of the layout, how we go through a problem. So if you have questions, email me, Scones, Mr. Scones. We could also do any kind of like Google Hangout if you want to go through any other problems live. So thanks a lot. Hopefully you found this helpful, and hopefully it will upload.